So prefix multipliers are a way to change from our base unit to a different unit. And what this does is keeps our numbers more workable. Okay. So instead of dealing with like, let's say something like 1,365 milliliters, we might find it a little easier to express our number as 1.365 liters. It just keeps the numbers a little easier to work with. What's going on with that? Let me exit some of this crap so I can try to fix my screen here. That'll help. Okay. So for example, the kilometer has the prefix kilo, or it means 1,000 or 10 to the third meters. So our base unit, and I wish they would draw this like this. Our base unit goes right here. So remember our base units, they're like meters, grams, seconds. Okay, those are our base units, right? And so we can use these prefix multipliers to express our base units in a way that makes a little more sense depending on what measurement we're dealing with. Okay, let's say we had 15 centimeters. Okay, well, 15 centimeters is what? If we convert that to, let's convert that to meters. Okay, so look here, we've got 0.01. Well, a centimeter is 0.01 meters, or 10 to the minus 2 meters. So that means there's 100 centimeters in 1 meter. So we can use these numbers as a conversion factor. Okay, we can say that 1 meter, okay, is equal to 100 centimeters, or we can say 0.01 meters is 1 centimeter. So I've got 15 centimeters, and 100 centimeters is 1 meter. So my decimal point would be here. I'm going to move it 2 places to the left. So 0.15 meters is equal to 15 centimeters. Okay. So basically we use these prefix multipliers as decimal places, as conversion factors, and we can move our decimal place to convert from one unit to the next. So let's look at some examples here. Let's see, do we have any examples with this? We do not. So let's say we had, let's say we had 1,300. I think I used this number earlier. Let's do something different. Let's say we had 2,650 grams, okay? And we want to convert grams to kilograms. Well, there's 1,000 grams in 1 kilogram, okay? So we're going to be using this conversion factor right here. All right, and so that means we're going to be dividing this number by 1,000. So the number is going to get smaller because we're going to a larger entity. So we're going to be moving our decimal point 3 places to the left to divide by 1,000. So that gives us 2.650 kilograms. Okay, so 2,650 grams is 2.650 kilograms. So that's the way we use these as conversion factors. And we're going to be doing that a lot in this course. So here we're talking about density, and we haven't gotten to density yet. So let's go ahead and talk about density before we work those problems. So density is a ratio of mass to volume, and we're going to be using density a lot because density allows us to convert volume to mass, or mass to volume. Okay, so we use density a lot. Derived units are a combination of other units. Okay, and we're going to talk about the fact that derived units actually are limited by the number of significant figures in them. So we're going to talk about that a little bit later on. Density affects whether a substance will float or sink in another substance. So in other words, if you had a tub and you fill that tub with water, let's say you put a piece of charcoal in it. If it's this kind of charcoal, then it's going to float on the water. Okay. And ice is a little less dense than water because water is 1 gram per milliliter. Okay, I forgot to define that. So let's say water is 1 gram per milliliter. Okay, and something that's less than 1 is going to float on top, and something that's greater than 1 is going to sink to the bottom. Okay, so that's why before the sugar dissolves in your water, it's going to sink to the bottom. But now ethanol is the kind of alcohol that people drink. Ethanol will not float to the top on the water because it mixes with water. It's miscible with water. So it doesn't form a layer. But if you put oil, let's say it's not in here, but let's say you put cooking oil in here. So what's going to happen with the cooking oil? It's going to actually float on the top, right? You're going to get 2 layers. You're going to get your oil on top and the water on the bottom. So you may have made a little like uh, thing that you can shake up with glitter in it, and it's got some food coloring in it, and the food coloring goes in the um, water layer and the oil goes on top, something like that. So made that in a little mason jar as a kid. So oil separates from water, but it's also generally less dense than water, so it will float on top. Now, some oils are actually more dense than water, but you wouldn't be able to buy those at the store. They're oily substances that are more dense, but that would be something like carbon tetrachloride, or chloroform. You wouldn't be able to buy that, but those actually will sink in water and form a different layer. All right, so table salt sinks in water until it dissolves, right? Glass would sink in water, aluminum also. So things that are more dense will sink. So all of these substances will sink. Notice that platinum is even more heavy than gold, or more dense rather, and gold is very dense compared to, say, aluminum. So if you pick up a piece of aluminum relative to a piece of, well, you might not have a chunk of gold that large, but let's think about that. Lead, maybe you've picked up a lead weight, right? You compare a similar sized piece of aluminum to a lead weight that you might have fished with, then the lead weight is going to feel a lot heavier because it's more dense. Okay, so the units of density are grams per milliliter, okay, or gram per cubic centimeter, because 1 milliliter is equal to 1 cubic centimeter. Okay, so density is grams per milliliter, so you can actually calculate density. If you know the mass and you know the volume, you can calculate the density of an object by dividing the mass by the volume. Okay,